We're here to talk more about securing live IP production workflows with Ryan Morris, our system engineer from Arista Networks. And one of the things in particular he's going to be talking about is securing PTP networks, which are very important for ST2110 applications. So, without further ado, take it away, Ryan.
Hi everyone, my name is Ryan Morris. I'm a systems engineer with Arista Networks. I've been a broadcast engineer most of my professional career, and recently made the move into the networking space. So I have a unique knowledge of this vertical. So just some context on network security as it applies to SMPTE 2110 environments. The architecture, the topologies, the hardware, the software solutions, they're very expensive, obviously. But the content that's riding over them is even more expensive. You have live sporting events, you have the Super Bowl, you have all this different content that's riding over networks constantly, 24/7. So we want to make sure that we're able to secure that, and by security, I don't necessarily just mean hackers coming in, breaking into a system, and taking over devices or stealing data. From a media perspective, from a 2110 perspective, I also mean ensuring that the content always remains active. Nothing is worse than signals going black on air. So, blocking certain traffic from entering, yeah, that's definitely a huge part of security. But just maintaining signal continuity, ensuring that the packets arrive, that's also a huge part of this. So, from a networking security perspective, this is called a CIA triangle. We have confidentiality, integrity, and availability. So from the confidentiality perspective, we're just talking about privacy, so maybe your authentication, your usernames and passwords. From the integrity perspective, just making sure that the content is not altered in any way. And from the availability perspective, ensuring that you're able to actually access this content at any time. So a lot of these policies are geared towards the IT environment, but the security that's in an IT environment may not always apply to a broadcast environment, partly because what we use in IT security, firewalls, are all software driven, and as everyone knows here, the multicast streams generated in 2110 environments are huge. They're 12 gigabits per second, and they're constant. The firewalls will not be able to handle that, as they're all driven by software, some are driven by software as opposed to hardware and FPGA based. So what should I do? I just want to go over a workflow right now. Something that could be typical in a 2110 environment, in a 2110 installation. So we inject a bad source into a network. Now, when we're designing a network, this is just an example, but if you have a monolithic switch, so just one switch with every device connected into it, a simple way of configuring it, the most expedient way of configuring it would be to have one large VLAN. It works. Customers do this all the time, and it's perfectly acceptable. It's efficient for moving flows around your network. But it can be dangerous, because when you have every single device in the same subnet, in the same VLAN, you have one large broadcast domain. So that means if you have a device that misbehaves and sends out packets that are being broadcasted, if you have a UHD signal that's being broadcasted in your entire network in one giant layer 2 domain, one large broadcast domain, it'll impact every single device in the network. And that can be obviously crippling for a live on-air system. So how do you attack something like that? Well, one way is to just reduce the size of the broadcast domain. So how do you do that? Well, you can split the switches up into different subnets, different networks, essentially. So if you have, If you have every device in its own subnet, then if it sends out a broadcast packet, it won't be able to impact every other device. So you can do that, and that can be a fine idea. That can be a great idea. But there's a downside to that as well. You lose the flexibility. You lose some of your flexibility in your network because you're making it far more rigid. So as broadcast engineers, when something doesn't work, some of the steps we take are to move devices from one interface to another interface. That happens all the time. But you can't accomplish that if everything is a layer 3 interface without changing the IP addresses of your data NICs at the same time, which, that could just be annoying, really. So if you want to be able to move devices around, as more and more customers are asking for now, from leaf to leaf, for example, in a spine leaf topology, we can take advantage of networking protocols like DHCP, where an IP address gets assigned automatically to your endpoint device. And this is becoming more and more common for broadcast vendors to support this on their endpoints. For the example, the JTNM 1001. So does that mean then that whenever you connect a device into your network, the address automatically pops up, is assigned, and then you're free to transmit or receive as you see fit? You can do that, but then there are, some customers may want to enforce more security. So that's where this comes into play, called 802.1x. You can apply this on your systems as well. So what 802.1x is essentially you have a client that you connect into a switch, which would be in this case called an authenticator. And the switches are connected to authentication servers. So when a client is connected into a switch, when you patch it in, and then the switch does not know about the source MAC address, the switch then contacts the radius server and it starts exchanging a messaging process that says, it's essentially just a very large authorization authentication process where commands are, this is used as a hub to send commands between the client and the authentication server. And if everything goes okay, if everything, matches, then this client will be permitted to transmit and receive traffic on this host. So this could be very advantageous for your network, but obviously it just adds, another layer of authorization and complexity into your system. Another topic that really is important in terms of network security is your bandwidth management, bandwidth mappings across your network. Now, broadcast vendors want to be able to control your traffic. It's important to them because they want to be able to implement solutions where your traffic is not going to be crushed on a link or saturate an entire link. So what they're able to do is restrict the bandwidth of a stream going into an interface. We call those ingress policers. So an example of that would be if you have a multicast stream, an audio stream, say 239.111, and you say that at most this can only be 15 megabits per second or 5 megabits per second, whatever you want to, depending on how large the audio is. Then if inadvertently that audio multicast stream becomes a UHD stream, that could also cripple your network. The ingress policers would say, hey, you have 3 gigs coming in, or 12 gigs coming in, and I am just expecting this to be an audio stream. It will limit the bandwidth propagating the network to whatever you set the ingress policers to. As for the stitching of multicast groups across a network, the broadcast controllers would also be able to do this because they will know the flow size of every stream. And they will also be able to identify how much of each link is actually being used. So if you have 3 links going from a spine to a leaf, and one is 99% full for some reason, and the other one is only 1% full, you wouldn't want to put the 12 gig UHD signal on the one that's 99% full, because then that'll crush every other piece of every other stream on your network. So the broadcast controller can then say, I want to put it on the other link, and that's very important. In these leaf spine topologies now, we don't want to just rely on only hashing algorithms to determine based on the IP address, which link does it traverse. We want to have more control. Broadcast controllers want to have more control over this. And then we have to talk about how does the broadcast controller actually talk to the network itself, talk to all the network devices on the network. We want to make sure it's secure. So how do we ensure that the network devices are all secure? We obviously won't we won't assign a password of just password or 1234. That would be, that would not be advised. We choose a more secure password. We also disable telnet on all of the switches and rely on, SSH, for example. We use HTTPS for added encryption. If we're using SNMP, then it should be read-only unless we, specify otherwise. And then we can also, take advantage of access control list as well on the control plane. So, in terms of access control lists now, we can use those to determine what is allowed where on the network. What groups are allowed to traverse specific links. And things like this are very handy, especially in 2022-7 environments, for example, where we have to connect the primary and the secondary, the red and blue networks together to allow for PTP to propagate. You never want to have traffic from the A side traversing over the B side, because you don't want those you want to have a somewhat of an air-gapped solution possibly. So you can create IP access lists or multicast boundaries to say, I do not want, any of these addresses to go out of a specific interface. And that can be very handy. There are other ways around that as well. You can just, create more stringent routing protocols. You can just not utilize PIM on certain links to enable multicast routing. But, there are various ways of doing that, and this is just one example. Access lists do get used very often, especially in 2022-7 environments. And you can also restrict it not just on the IP address, but also the MAC address. So access lists, we really should take advantage of them. They're very beneficial for typical media systems. Next up is PTP security. PTP is not secure. There are methods to make it more robust, and harden it, but overall it is not a secure protocol. Part of the reason why is, as an example, any device possibly can become a grandmaster for a system as long as you can be a master and as long as its priorities are configurable. So priority 1, priority 2 values, for example. So we want to eventually be able to limit what devices can become a grandmaster. I wouldn't want necessarily a microphone to be a grandmaster over a legitimate grandmaster. So it is not inherently secure in that way. PTP version 2.1 will hopefully be adding some security as well. So I want to now review some of the key points in hardening a PTP distribution network to add security for the timing of your system. So take advantage of PTP role master. So take advantage of boundary clock, take advantage of PTP role master. PTP role master ensures that any device that's connected to that specific interface will not be the grandmaster for the entire system. It is one of the most powerful commands for PTP. It's used widely in the industry. I highly recommend we use this wherever possible. The only time you should not have PTP role master enabled on a device or enabled on an interface is if it's connected directly to a grandmaster, such as the clock here, or going from switch to switch. Because in an environment like this, for example, Grandmaster A or Grandmaster B might be elected the Grandmaster, depending on their priorities. So we might need PTP to go from the Grandmaster to go from here to here, or from switch 2 to switch 1. We can also implement an IP access list as well on these networks. So we can say on, for example, over here, only accept 224.0.1.129 from the PTP source IP on this switch here. We can add that type of security as well, just to harden the networks. That doesn't make things perfect though, because someone can possibly spoof that IP address or connect a device directly into the network with that IP. These are just steps to, in a regular environment that's not being interrupted by, devious people, to prevent them from, this is a way of preventing the network from going haywire, essentially, from their PTP distribution network. And also controlling PTP management messages. If the standard says every device will send out PTP management messages, but you don't necessarily want all your slave devices to respond to every PTP management message, because if one does and then others do, you can see that the amount of messages flooding your network will grow exponentially, and that can cause essentially a disruption of service. We never want that to happen, and that's just something that can be more aptly implemented on slave devices. So network security isn't just about blocking traffic. It's not just about configuring the system to making it as robust as possible, but it's also about being able to identify when problems occur. And for this, we definitely need to take advantage of the telemetry that's available on networking switches. Create NMSs or purchase NMSs that will be able to access your counters, access the switches, and not just look at the statistics, but maybe come up with trends as well. So if if a link has 1 gig of bandwidth on there, for example, or 12 gigs of bandwidth, and then for months in a row, and then all of a sudden it's up to 100 or 80 gigs per second, you may want to flag something like that as being abnormal. And NMSs allow this. NMSs can allow this to happen. It's about being steps ahead, so that if a problem does occur, you may be ready for it. But also, if you need to analyze the issues. If something happens at 3:30 and if it happens at 3:30 and it's only 4:30 when you realize it, you want to be able to access the logs from any time at all, from any time back in the past, so that you can readily study it and prevent it from occurring again. And acquiring switches now generally make data readily available, but you also have to be able to use it in a productive way, and that's really important, to be able to take that data, harness it, and just make your networking facility more efficient. So this guy here is just amazed by the amount of telemetry on some of these systems here. It's crazy. So he's looking at PTP traffic, and he's able throughout the network, and he's able to determine the performance of all the grandmasters, the skew on all the across the boundary clocks. He wants to make sure that all boundary clocks are locked to the same grandmaster ID. He wants to see finer trends, and he wants to look at counters. And you can even write scripts to act on the switches if certain counters if certain counters increment to a certain amount. And what are we doing in the standards bodies right now? Well, this is starting to become a more important idea, and we're really discussing all this right now. We don't yet clearly have defined a method of security in broadcast networks. We do for IT. There are many methods in IT networks, but not necessarily broadcast networks. And that's what we're trying to do. That's what the JT&M triangle down there at the bottom, phase 5, is trying to accomplish now. So we're using various checklists that devices need to be able to support. Penetration, pen testing, disruption of service, PTP role master, making sure your software is always up to date. Some UDP ports are only UDP ports that are accessible are ones that are absolutely necessary, and an intruder can't get in over unknown ports. This is all part of the EBU of the checklist, and we need to do more than that. And I'm confident that as more and more of these deployments become widely used, as the migration continues, more security measures will be taken in these types of systems. So, to conclude, security is vital. It's not an afterthought anymore in the media environments, and it needs to be built from the start. But you really need to decide, based on your system, how much security you really need. When I was discussing the policers, maybe you want to put those on every stream, but maybe you won't. Maybe you only want them on the audio and the data streams, but not the video, for example. An example of why you wouldn't necessarily want all the video streams to have policers is if for certain productions, a stream might be 3 gig, one show, and then UHD, another show. Then if that were to occur and you had a policer on that flow, you would need to go into the network and make some configuration changes. So, there are definitely ways to make your network more secure, but it's really up to it's up to the end users to determine how secure they want it to be. Because as you possibly add more and more security, you may lose some flexibility in your network as well, in all your devices. And thank you very much.
Thank you, Ryan.